This is Advanced Math, Lesson 3.7, Unit 3, Lesson 7. Okay, 3.7's title is Arc Length and Quadrant Constraints. Quadrant constraints. All right, part 1, arc length. Okay, arc length formula. I'm going to put the picture here. Before I give you the picture, I'm going to give you the formula. S equals theta r. S equals theta times r. I will explain what each of these stand for. So let's get our picture in over here. Before I get the picture, let's bubble this guy in so we remember that is a formula we will need to have memorized. Let's draw our circle. With the center. I'm going to call this theta. So obviously theta is the angle, and what you'll have to remember is that theta is always in radians. So theta is an angle, and that makes sense. Theta is typically used to name an angle. It's an angle, but it's always in radians. And you will have to know that for the test, otherwise it will mess you up. Theta is always in radians. Okay, r is what you think it would be, is the radius. It's this right here. R equals the radius. And what does S represent? This is the S right here, and it's something you learned in math too. S is the arc length. Not the arc measure, the arc length. It's like getting a piece of the circumference and just snipping off this little piece, laying it out and measuring it. It's the arc length, the length of the arc. All right, so S is arc length, theta is an angle and always in radians, and r is the radius. An easy way to remember this formula is we are eagles and we soar like an eagle. Can't spell, but we can soar. We soar like an eagle. If you can remember that, you'll have the formula memorized come test day. All right, number 1. Find the angle in radians. Radians. Find the angle in radians. All right. We're going to do this for 1 and 2. So let's get our circle down. Here's theta. This is 3 centimeters, and this is 4 centimeters. Okay, so the arc length out here is 4 centimeters. That's the S, and the radius is 3 centimeters. Okay, so using our SOAR formula, S equals theta times r. S, what are we looking for? We're looking for theta, which means we should know S and r. S is the arc length, 4 centimeters, equals theta we don't know. R is the radius, 3 centimeters. And I'm looking for theta, so we divide both sides by 3. And theta equals 4/3. theta equals 4/3. Now, you may not say it or write it, but it is in radians. You should recognize it. Why is it in radians? Because this formula is set up that when you solve for theta, theta will always be in radians. When you plug in theta, theta should always be in radians. So 4/3 of a radian. Okay, number 2. Same question, find the angle in radians. Let's get our circle down. Radius is 6 centimeters. And theta is the bigger angle here. Theta is not this little angle in there, it's the bigger angle. And the arc length is this bigger piece out here. It's the major, not the minor. It's the bigger side, the major arc type piece. Okay, so that is 24 centimeters. Okay, same formula. The SOHR formula, S equals theta times R. S is the arc length, the big piece out here, which is 24. Theta we don't know, that's what we're trying to find. Times the radius is 6 centimeters. Divide both sides by 6. Theta equals 4, and not just 4, but 4 radians. If you don't write down the radians, that is okay, as long as you know and you recognize that it is a radian that you just found. Not a degree, not inches, it's a radian. Okay, number 3. Find the angle in degrees for a circle with a 6-inch radius and an arc of 5 pi inches. Okay, really quick, these answers up here had no pi. Now remember, like 4 pi over 3, pi over 2, 2 pi over 3. Those are answers in radians we typically use and see and write. But remember we talked like second day of notes, second or third day, the pi isn't always there, and kids get confused when the pi isn't there. Like 1 radian is still a radian. Pi or not, the pi is not necessary. Okay, this one does have the pi, so we're going to work the pi in there. All right, no pictures given. You don't need a picture. If you don't like it, you don't need it. I'm visual, so I like to get my pictures in there when I can. Find the angle in degrees for a circle with a 6-inch radius. With a 6-inch radius and an arc of 5 pi. Okay, I don't know how big theta is going to be, so I'm just approximating. And this here is the 5 pi inches. Okay, so S equals theta R. S is the 5 pi. Theta is what we're looking for, and the radius is 6. All right, so we divide both sides by 6. Theta equals 5 pi over 6. Okay, I will tell you right now, this one is quite often missed on the test. So I'm just going to put a note here, and I'm hoping you guys mark these when I tell you these are test questions or these are the ones that kids miss on the test. When you study, and yes, you should study, go back and look at your notes and look for the ones that I've marked test questions or most missed on the test, because kids quite often make these mistakes. And here's the mistake they make. They stop here and they say good and done. We stop there, it was good. Oh, we could even put the R for radians. But if you stop here, it is wrong, and you're not going to get credit for this on the test. I'm hoping you guys recognize that they asked for the answer in degrees. And this is not a degree, this is a radian. So you do have to take the time to convert, and we do know how to do that, from radians to degrees. So let's do that now. 5 pi over 6 radians times our conversion factor. Is it 180 over pi or pi over 180? I want to end up with degrees, so I'm going to have the degrees on top over pi radians. Radians always cross out. Pi is a bonus. In this case, the pi does cross out. 6 goes into 180, so I can reduce that as well. 6 is 1, and 180 becomes 30. So you have 5 times 30 degrees. So theta equals 150 degrees. All right, so be careful with that one on the test. Read carefully. Degrees, and remember, oh yeah, this is going to be a radian answer. I will have to convert at the end. All right, moving on. Number 4. Find R where S equals 26 feet and theta equals 90 degrees. I'm going to have you hit pause. Let me finish this off first. I'm going to have you hit pause, write this down first. S equals theta R, plug things in, work it out, and then unpause and check our answers at the end. Okay. S is 26, theta is 90, and the radius is what I'm looking for. Now, if you've already worked it out and you did it differently and you're like, wait, I didn't do that, I am making a mistake, and I'm making the mistake purposely because kids make this mistake quite often as well. Okay, so know that going in. If you did it this way and you're like, wait, I did it that way, then you're definitely paying attention so you don't make this mistake. Excuse me. So you reduce. R equals 26 over 90 reduces to 13 over 45, and kids say, oh, that is my answer. Now, it is wrong. The whole work is wrong. So if you did it, you're paying attention. If you didn't do it, you're waiting to see what it should come out to be. Here's the mistake. Theta is in 90 degrees. Remember, the SOAR formula, theta is always in radians. You plug in a radian, your answer is a radian. And this is not a radian, this is a degree. So what is 90 degrees as a radian? Pi over 2. So pi over 2 is what we should have plugged in right here. So 26 for the S equals theta is pi over 2, and R is what we are looking for. So we go through and we multiply both sides by the reciprocal. 2 over pi, 2 over pi. All right, so the 2's reduce, the pi's reduce, and I'm left with R equals 2 times 26, which is 52, over pi times 1 is pi. R equals 52 over pi, which is 52 over 3.14. And when you plug that in your calculator, you get 16.6 feet. So your radius is 16.6 feet. Okay, moving along. That's it for part 1. We're moving on to part 2. Part 2 is quadrant constraints. Okay, quadrant constraints. State the quadrant theta is in. State the quadrant theta is in. Number 1, sine of theta is less than 0, and cosine of theta is greater than 0. When you're looking for these constraints, you're always going to be given 2 pieces of information. Just that by itself is not enough. You need 2 pieces of information, and let me show you why. When you use your All Students Take Calculus, let's pretend for just a second that the second piece was not given to me, and all I have is sine is less than 0. Sine is less than 0 means sine is negative. All is positive, sine is positive, tangent's positive, cosine is positive. If I'm looking where sine is negative, it's not going to be in these 2 quadrants. I can automatically cross those 2 out. I know that because they're all positive and sine is positive, and I'm looking for the place where sine is less than 0. So that would be down here. If you remember when we filled them out on this chart here, you see where sine is positive here, sine is positive there. We're looking for the places where sine is negative. Sine is negative here, and sine is negative there. Okay. So it's going to be one of these 2 quadrants. So if this was all I gave you, that's not enough because we don't know if it's quadrants 3 or 4. So that's what you need the second piece of information for. So we look from these 2 that are left, from only these 2 that are left, because I've already crossed out the top 2. Where is cosine of theta positive? Well, according to this is the only place from these bottom 2 quadrants that cosine is positive. Yes, cosine is also positive up here, but I already crossed it out. So quadrant 4 is the answer. Let's try another one. Number 2, cosecant of theta is greater than 0, and cotangent of theta is less than 0. Okay, cosecant is the reciprocal of what? Sine, so you can write that small there. That's the same thing as saying sine is greater than 0, which means positive. Cotangent's reciprocal is tangent, so tangent is negative. And let's set up our All Students Take Calculus. It doesn't matter which one you start with, technically, first or second. I just start with the first. I'm looking where sine is positive, so I'm crossing out the bottom 2 this time because they're all positive in quadrant 1 and only sine is positive in quadrant 2. Therefore, those are the only 2 places where sine is positive, not the bottom 2 quadrants. So from those 2 left, where is tangent negative? Well, it can't be quadrant 1 because they're all positive, so it must be quadrant 2. Why not quadrant 1? Because they're all positive. So quadrant 2 is the only place where sine is positive and tangent is negative. No other quadrant would work. Quadrant 2 is your answer. Number 3, find the 6 trig functions. Find the 6 trig functions given tan of theta equals -12/5, comma blank. There's going to be more that I give you, and this is still part of the quadrant constraints. Remember where I said up here you need 2 pieces of information in order to get down to 1 quadrant? This is the same thing. Here's the first piece. I haven't yet given you the second piece. All right, so let's sketch and see again why we need that second piece. So here's our X and Y axis. I haven't graphed this piece yet. Tan of theta is -12/5. All students take calculus. Okay, if tangent's negative, that means it can't be in quadrant 1 and it can't be in quadrant 3 because all are positive here and tangent's positive here. So I know for sure it's in one of these two quadrants. I don't know which one because I haven't been given the second piece of information. So that's why this is needed, so you can constrain yourself, get yourself down to one quadrant. So this second piece will always be given. I just want to make sure you understand why it is given. Okay, sine of theta is less than 0. Sometimes they'll give it to you as a freebie and say theta's in quadrant 3 or theta's in quadrant 2. When they don't give it to you as a freebie, they're going to give you the second piece of information. From these two quadrants, where is sine less than 0? That means negative. From these two quadrants, the only place it could be is quadrant 4 because here sine is positive. So theta, this technically out here is theta, but we do put it there as a reference angle. Theta is in quadrant 4. Why? Because that's the only place where tangent's negative and sine is negative. All right, now it is important that you draw your picture. The mistake kids make on homework and quizzes and tests, they just draw it like this. And they put the right angle here, and they put theta there, and then they label opposite adjacent, and it does mess things up. So don't just randomly draw a triangle. Put it in the proper quadrant so you get your sides labeled properly. Okay, theta is always by the origin. Opposite over adjacent, 12, 5. That negative, I'm going to erase it really quick or white it out. That negative may say like be placed in the middle, or you can't just assume because it's say at the top that it's connected with the 12. You really have to look at the problem. Which one's negative here, the 5 or the 12? And indeed it is the 12. Again, you can't just assume because you have to look at what number really truly is negative. In this case, 5 is positive and 12 is negative. Positive, negative. You do your Pythagorean's theorem. 5 squared plus negative 12 squared equals c squared, or you know it, you can work it out, or you know what, I'm going to put it here. 13 is what it does come out to be. And now we're ready to find sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. And tangent's opposite over adjacent. And indeed, it came out where tangent's negative 12 over 5 and sine is negative, and that is indeed what ended up happening. Okay, reciprocals. Remember, s never goes with s, so this is going to be cosecant. Cosine is secant, and tangent is cotangent. And it's just reciprocal functions. So negative 13 over 12, 13 over 5, negative 5 over 12. So this would be an example of if they gave you this, cotangent of theta is negative 5/12, and you draw your picture, you can see that the 5 is not negative, it is the 12. So you want to read your graph before you put your negative in. All right, that's it for this problem. We do have a few more to get through. Okay, part 3, find the missing angles. This is on the test. Find the missing angles. And kids tend to struggle with this piece. Some kids either really get it or they really struggle, so you want to make sure you are paying attention. Find two solutions. Two solutions, comma, give solutions in degrees. I'll fill that in after. And in radians. All right, so this is 0 degrees is less than or equal to theta is less than 360, and this is 0 is less than or equal to theta, which is less than 2 pi. Okay, so technically on a graph, we could go around and around and around 2 pi, 4 pi, 6 pi, 12 pi. But this wants us to only do one revolution, one time around, from 0 to 2 pi. Now make sure you notice that it equals 0 and 0, but it does not equal 360 or 2 pi. So if your answer, you end up on this line right here, and you're tempted to say, oh, my answer is 360 degrees. Do not, because you're going to get it wrong. 360 is not part of our solutions. 0 would be your answer. We'll see these more, and I'll explain a little more as we go. Okay, just a quick side note, notation, interval notation you have seen before. So when your textbook writes it like this, or like this, you know what that means. Interval notation, you have seen that before. From 0 to 360, including 0, not the 360. From 0 to 2 pi, including the 0, not the 2 pi. All right, and I'm just showing you that because your textbook will use that notation every now and then. Okay, number 1, sine of theta equals root 3 over 2. Okay. First thing you want to do is find your reference angle. So that's the first suggestion I have for you. You can use your unit circle, you can use your hand trick. I will show you both. I'm looking for when sine is root 3 over 2. Using your hand trick, I would put this finger down because I want the y to have the 3, root 3 over 2. This is 30, this is 60, so 60 degrees would be my reference angle. Or use your unit circle. When is the y value root 3 over 2? 60 degrees. Okay, it's positive. All students take calculus. What two places is sine positive? Quadrant 1 and quadrant 2. So is 60 degrees one of your answers? Yes, it is, because it is in quadrant 1. What is 60 degrees in quadrant 2? 180. Take away 60 is 120. Again, you can use your unit circle. What two places is sine positive root 3 over 2? At 60 and 120, which is also pi over 3 and 2 pi over 3. Pi over 3 and 2 pi over 3. And we're writing 2 because it asked us to there, to write in degrees and radians. Okay, number 2, cosine of theta equals negative root 2 over 2. Now, we don't write it that way. I don't know if your teachers did last year, but the way we write it in our unit circle is negative 1 over root 2. Recognize that those are the same thing because your book will write it like this, so just recognize that it is the same. Okay, reference angle, I'm hoping everyone can see that it is 45 degrees. What two places? All students take calculus. What two places is cosine negative? Well, right here they're all positive. Right here cosine's positive, so it must be quadrant 2 and quadrant 3. So 180 minus 45 and 180 plus 45, which is 135 and 225. I know my reference angle is 45, so my denominator is going to be 4. So 4 over 4. Backtrack 1/4 is 3 pi over 4. Plus 1/4 is 5 pi over 4. Or use your unit circle if that helps you. But again, you want to get to the point where you're not using it as much. Number 3, sine of theta equals 0. Recognizing that that is a quadrantal, so get a visual. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Sine is y. You're looking for when your y value is 0. and that is at 0 and 180. If you say, oh, 180 and 360, that is wrong, because we can't use the 360, we use the 0 instead. So 0, 180, or 0 and pi. Number 4, cosine of theta equals 0. Okay, I'm going to use this here. Cosine are the x values that happens here, and that is 90 degrees and 270, or pi over 2 and 3 pi over 2. Number 5, cosine of theta equals 1. Now, cosine of theta, remember our restraints here are between 0 and 360. I can only go between 0 and 360. How many places between 0 and 360 is your x value 1? That right there is the only place. There is only one place, so you only have one solution on this one. And would you call this 0 or 360? You would have to call it 0. You cannot call it 360. So 0 degrees is your only solution. Now, it had asked for it in degrees and radians, so we also have, as our other solution, 0 radians. Okay, so by 2, there's 2 degree answers, there's 2 radian answers. 2 degree answers, 2 radian answers. This one has only 1 degree answer and 1 radian answer because there's only one place where cosine is 1. Sorry, I was pointing the wrong one. There's only one place where cosine is 1. Okay, number 6, tan theta equals 1. This is another one kids mess up because they see the ones, especially after we were dealing with these ones here, and they look on the unit circle, they look at the quadrantals. They look at these 4 quadrantals to find their solution. When tangent is 1, it's not one of your quadrantals. It's only when cosine of theta is 1 or sine of theta is 1 that you're going to be on one of your quadrantals. Tangent is 1 at one of your 45s because 1 over 1 or 1 over root 2 over 1 over root 2 is 1. So 45 degrees is your reference angle. What 2 quadrants? All students take calculus. What 2 quadrants is tangent positive? Quadrant 1 and quadrant 3. So is 45 degrees one of your answers? Yes, because it's in quadrant 1, and then 180 plus 45 is 225. So this is pi over 4, 4 over 4, 5 over 4, 5 pi over 4. And that is it for this lesson.